All right, continuing on here. Boom, we're going to take a look at 7, which says find the area between f of x equals sine of square root of x and the x-axis. Now, sine of root x is going to look something like, I'm going to graph on my calculator in a second, okay? But just in case you do this by hand, sine of root x is going to look something along these. It looks like a sine curve, right? Now, these are going to be getting smaller or bigger. Let me think here. 100 is going to come down to 10. So smaller, I guess. Yeah, okay. By the way, if you had to find the area specifically for this, you'd have to find like this area and then find this area and change its sign and then this area. If you had to do it by hand. But what we're going to do is graph the absolute value of this thing. Since we just want the area, right? Area has to be positive. And that's going to turn this into a curve that looks like this. Cool. And it's going to turn all the area positive. It's going to flip up the negative pieces. All right. So anytime you want to find the area and you have a calculator, just graph the absolute value of that thing. And that'll work. So we're going to do sine, so absolute value. So it's math over a number, abs. There you go. Sine root x. All right, you don't have to do this. You can just do it right from the home screen too. Okay, so that's absolute value of it. I just want the graph to show you what this thing looks like now. So the window is going to go, all we care about is 7 to 15. And sine is between -1 and 1, but we're taking the absolute value of it, so it's going to be between 0 and 1. So if you graph there, you're just going to see what the graph looks like. So it's going to come down and bounce. It looks like a V, but it's really not. It's really a curve, like if we were to zoom out on that, like 0 to 15, you'd see it bouncing. Okay, but that's about it. And that's just going to bounce and come back down again too, but we just want to go 7 to 15. So something I haven't shown you yet in class is from this screen, you can actually integrate. Instead of going to the home screen, if you hit second calc, so we usually do 0 or maximum, min, or intersect, but the very number 7 is integral f of x. So if we go 7, that's going to integrate this function from wherever we want. So I'm going to say integrate from 7, enter, to 15, enter, and it fills in the area really pretty for us. There it goes. And it's going to spit out an answer. Boom. Area is 2.53196. So what, 2.532? 2.532. And again, that's just the area from 7 to 15 of the absolute value of sine root x dx. Not too bad. All right. Number 8 is about the rate of change of students in a school. So we're just given the total rate of change, so if that's positive or negative. Why is this typed over here? Huh. Oh, I did that earlier, I think. Okay. Don't pay attention to this over here. RFT is measured in students per hour. At t equals 4, the number of students in the school was 1450. So, again, before we even look at any of these questions here, okay, in your head you should be thinking, all right, this is the derivative of the number of students, right, which I'm going to call A of t. So the derivative of it is that. So if A of t equals the number of students at any time in hours, then A prime of t is the rate of change of students. Cool. So the average rate of change of number of students on the time interval 0 to 7. So we want the AROC, right, of the number of students. That's A of t. So that should be A of 7 minus A of 0 over 7 minus 0. And also, as in previous questions, because I know there are 1450 at time 4, I know A of t has to be 1450 plus the integral from 4 to t of r of x dx. That's going to tell us how many students there are. So I can find A of 7 and A of 0 using that formula. Or you can remember, like we said before, the average rate of change of the number of students is the average value of the rate of change of students. So we can also just do this magic right here. Okay, so we can do that right in our handy-dandy calculator. So it's 1 divides 7, math 9, 0 to 7 of r of t, which is 20 square root. No. Get out of here, dummy. second square root, there we are, of 3t plus 1. So 3x plus 1. Cool. dx. Right? 23x plus 1. We got that. dx. Oh, no, there's a cosine in there. See, that's why I double check here. So get out of the square root. There we are. Cosine pi x over 3. There we go. All right. dx. That looks good. So let's double check again. 1/7 integral 0 to 7 of 20 root 3x plus 1 cosine pi x over 3. Sounds good. dx. Boom. And that's going to give me 9.183. And notice I'm writing out the formula I'm using here. Okay, so you don't need both of these. Either this will work if you do it that way, or this will work. But you should write the formula out you're using if you're going to use your calculator. Okay, and since this is average rate of change of students, this will be students per hour. All right, hold on. Let me get rid of this here. This is bothering me. There we go. Okay, so to the nearest student, why is it starting on C? It's weird. It's just a number from up here. Okay, that's just weird number. To the nearest student, what's the max number of students? So we need to find where r of t is 0, because that's a prime of t, right? Because we're going to maximize number of students, and that function is a. So we find its derivative, which is given to us, and we solve that. So let's go into here, and I didn't put in the y equals, which I should have. So I forget what it was already. There we go. 22nd square root. This digital calculator, while it's nice for class and stuff, it is super duper slow. And if I hit the wrong thing, this is annoying. Plus 1. There we go. 20 root 3x plus 1. Cosine of pi x over 3. Boom. Root 3x plus 1, cosine pi x over 3. Looks good. Cool. And we went over from 0 to 7. So we're going to graph from 0 to 7. And we're really looking for zeros of this thing. So as long as our y's cross through 0, we're fine. I'm going to go negative 5 to 5. I usually do negative 1 to 1. It doesn't matter too much. Ellie, what you doing over here, bud? For Scratch?
No, it's this video about loops and if I need help.
All right, give me 1 second, big guy. So this is our derivative of the number of students. So you see it's positive to negative, so that could be a max right there. Then it goes negative to positive, which is going to be a minimum, but then it's positive until the end, so that also could be a max. But we're just going to find those two values. And these are going to be nice numbers because of the pi over 3 in there. But we'll find them with the calculator here. So we need the 0, right? Boom. You can see it's between 1 and 2. It's 1.5, but we'll find it for you. Boom. And it's going to say 1.5. There you go. And the other one's going to be, what is that going to be? 1, 2, 3, 4, 4.5. Okay. But you're going to write t equals, let's find it too, just to make sure and show you how to do this. So 0, boom. It's between 4 and 5. Cool. And it's not 4.5 because it looks like 4.5. It's 4.5 because I know what makes cosine 0. Okay. We're going to get t equals 1.5 and 4.5. So then all we got to do is find the amount at the endpoints and at the critical values. All right. And we're going to do that on the calculator by using this formula right up here. The amount we know is 1450. So it's going to be 1450 plus math 9. 420 is what we need first to find the initial start. Now, a lot of times they give you the starting point. I made this question up, and I give you the starting point just to be kind of a pain in the butt. So bars, I put this in the y1 as where I put RT, dx. So it's going to give me the amount at 0. And we should see that's a little bit, yeah, okay, because our derivative, remember our graph? The derivative was positive there. So wait a minute here. Something's wrong. 4 to 0. That should be less than 1450.
Watch this.
Because you're going backwards, you got to take away a positive area. Why is this not right? What's my y1? That's good. Oh, because at 4, it's negative down here. I'm just looking at this very first positive interval here, guys and girls. 4 is, yeah, way up here. So we're taking away all this negative area, too, which is going to add back because we're going backwards. I just confused myself. Anyway. Again, I'm just trying to think and make sure these answers make sense. Okay, so 1530.451. But because it says to the nearest student, I'm just going to say 1530. Okie dokie. And then we're going to say a of 7, so second, enter. Let's go back and change that 0 to a 7. That's going to be the amount. It's 7. That's 1594.7, so 1595. Boom. And then we got to find it at 1.5. So the calculator's doing all the work, but you got to go back and type it all in. So let's change a 7 to a 1.5. And this should be a fairly big number. There we go. 1561 is what that's going to round to. And then at 4.5, we're expecting that to be a minimum because the derivative went from negative to positive there. And that's going to be 1441. All right. So the maximum number of students is 1595. And you just write that. And again, this is how you justify your answer in finding a max or a min. So the max number of students is 1595 at t equals, what was that, 7 hours? All right. Last one. Now we got this rate in, rate out question with all these questions down here. Let's talk about this. So, the rate at which gas is bought at the local station for a 12-hour interval is R of t. So R of t is the rate out. Okay? And that's for 0 to 12. At 8 a.m., okay, now 8 is for 0, okay? So it says hours after 8 a.m., and we're starting from 0 to 12, so 0 is 8 a.m. Okay, so at exactly 8 a.m., a fuel truck stops in and starts putting gas back in, okay, at the rate of. So H of t is the rate in. Hey, E, you all right, dude? What are you doing? You recording that? Nice work. So we have a rate out and a rate in. So the total rate of change is H of t minus R of t. So that's the total rate of change. Now you'll notice in the last question, yeah, my son's recording himself making weird noises. God, that looks so. I'm gonna try one more time. Change, okay. In the last question, to go up here real quick, I gave you the rate of change total. It wasn't a rate in, rate out. It was just R of t. When they give you a rate in, rate out, you got to put them together to get the total rate of change. So this is really the derivative of, I'm going to call it G for gas. Okay, that's G prime of t. These other things can tell us stuff, but they're not the derivative of the amount of gas because it's just the rate out and the rate in separate. Cool? And we know the gas station has 9,453 gallons at 8, which is our 0 point. Okay? Also to pay attention to, the truck is only refilling for the first 6 hours. Okay? So that's until 2 p.m. So that's going to matter because then our derivative is going to change. All right? But for right now, we have that the amount of gas we have is equal to the amount of gas that we started with, which is 9,453 gallons, plus the integral from, we're starting at 0, because that's what we knew we had that, to t, of H of t minus R of t dt. But this is only good for 0 less than or equal to t less than or equal to 6. That's kind of close to that. Let me lower that down some. Okay, because it's 6, H of t changes. It just stops, right? They're only filling it up until 6. So after 6, the derivative is going to change, but we don't know what that is yet because we've got to find the amount of gas at 6, which we'll find later on. Okay, so A says the price for a customer to buy gas is $3.48. How much money does the gas station make off sales? So we got to take how much gas was bought, which is the integral from 0 to 12 of R of t. That's going to tell us how much gas got bought up. Then we need to multiply that by $3.48 for each gallon. So that's going to give us this amount right here. And over here, I'm going to put in to my y1 R of t. So we got to remember that's R of t. So it's x squared minus 8x plus 25. Cool. I'm going to put in the other one, h of t as well, is x cubed minus 6x squared plus 3t plus 25. My kids are playing with Scratch, the programming language over there. Who knows what monster they're creating. X cubed minus 6x squared plus 3x plus 25. Okay. So let's quit that out. But for this question, we don't need the rate that it's brought back in. We need the rate that it's bought out, because they're paying $3.48. Customers pay $3.48 to buy it. So it's $3.48 times the integral from 0 to 12. Ooh, I'm getting blown up on my phone. Of the rate out, which we put into y1. So I got to keep that in track of that. y1 dx. And they're going to bring in a whole bunch of money, $1,044 exactly. Great. Okay. And look, again, note I wrote the integral I did. I'm not just writing my answer. I wrote what math I did in my calculator. How many gallons of gas do they have at 2 p.m.? Now that has to deal with how much they had, how much got bought out, and how much got brought in. So that's G of t. So we need to do 9,453 plus the integral from 0, because 2 p.m. is 6. We can use h of t that whole time. H doesn't stop until 6. If this was past 6, we'd have to do a little bit extra step here. But for right now, because H is going the whole time till 6, we can use it like that. So it's going to be 9453 plus. Oh, notice in part A too, sometimes kids think the 9453 should be a part of that. It doesn't matter that gas was there to begin with. All that matters for question A is how much gas was bought during that time. And that's the integral of R of t. That's all. Okay, it's the change that happened. It doesn't matter how much gas they have in the station. It's how much they sold. So, but for B, it's how many gallons do they have. It's an amount now. So we got to take what we had and add in the integral from 0 to 6 of the rate in, which was y2 minus the rate out, which was y1. Okay, so that's what we had plus the integral of the rate of change, which is the total change. It's going to tell us 9,471. And that's going to be in gallons. Now, what's the max amount of gasoline between 8 and 2 p.m.? First thing we got to do is find the derivative of the amount of gas, which we already know is H minus R. We need to set that equal to 0. We need to solve it. So, check this out. We can also just find their intersections, but I'd rather graph them. So look, check this out. I'm going to do vars y2 minus vars y1. And that's going to graph H minus R. But I don't want to graph these anymore, so I'm going to go up here and hit enter on their equal signs, and it's going to turn them off. Cool. And now I got to graph that from 0 to 6. So let's change my window. We'll go from 0 to 6. And again, y can go anywhere because we just want to see it go through 0 because that's what we're looking for. So graph. And it's positive, which means we gain gas for the first little bit of time. Then the derivative becomes negative at like 2.2, it looks like. And then it's positive again after that. So the maximum could happen right here, because that's where the derivative changes from positive to negative. It could also happen at the end, because it's increasing until the end. But we got to find those zeros, so let's go ahead and do this. Second, trace 0. There's one between 2 and 3. It looks like it's like 2.2. It's I can't even read that. 2.381966. Okay, but what I'm going to do here, like I do always, is quit out of here. And I'm going to store that as alpha A. I'm going to write on my paper 2.381966. 2.381966. I'm going to say that equals A. And we also got another one. I'm going to write right underneath of it. T equals. We got to find that second 0. Second trace case, we want the 0. It's between 1, 2, 3, 4, and 5. 4, enter. Right bound, 5, enter. It's right in the middle. Just hit enter to guess this for you. And we're going to take that number, second quit, and store that as B. It's 4.618034. 618034. 0.618. I forgot already. 618034. Good God. 034, yes. Okay, that's a 4 there. Cool, I'm going to say that's B. So I got to erase my work over here because I did not space this out correctly when I formatted this document. All right, and then all I got to do is find the amount. Now remember, I had the gas G of T defined already, right? So as long as that's defined on my paper, I can say we need G of 0, which we were given, is 9453. We need G of 6, which we found in the last question, right? 9471. We need G of A, and we need G of B. These are all G's, sloppy G's. Okay, so to find that, I'm just going to come up here and steal this thing again. Boom. There we go. So what just happened there? So we're going to do to A. I passed it already. So we hit alpha A right there. That's going to find the amount at A, which is 946719. 946719. Okay. And G of B. Just going to go back here and change that A to a B now. Alpha B. Boom. And that is 9454.197. 9454.197. So the maximum happens, you can see here, the greatest of these is 9471. So, in write a little sentence answering the question. The max amount of gas is 9471 gallons. Remember your units. At T equals 6 hours. All right, so pretty standard. Now, there we go. At 1 p.m., the amount of gasoline at the gas station increasing or decreasing. Now we just want, again, that's the derivative of the amount, which I've erased, but that's G prime of, at 1, that's 5 hours after we opened up. But that's just the rate in minus the rate out. If it's positive, then more's coming in than is going out. Hey, guys, chill. Chill. Gentlemen.
Let me go.
I'm torn between yelling at them when I'm recording this or just punishing them later. Yeah, you can wait a minute. You're gonna be in some trouble.
You can wait a minute. You don't want to.
You're gonna be crying. I'm gonna record that, and some of my students can see it too. All right. We need to do. I put it in Y3, right? So we can just do Y3. Hey, go upstairs, both of you now. Go. Elliot, put it down and go. So Y3 already was our rate in minus our rate out. I put that in there already.
Let go.
Okay. I'm very upset. It's 5. Now, because it's greater than 0, the amount of gas is increasing. All right. So let me erase all this junk over here. You can write this a couple ways, but the easiest way is to say H of 5 is greater than R of 5, which means the rate in is greater than the rate out. So we're getting more gasoline in than we are taking out. Cool. And then the very last question says, the gas truck stops filling at 2, but people continue to buy the gas. How much gas is at the station at 4? So it's 2 hours after we close. So all we need is another amount function that is based off our derivative that just has gas going out, not in. So G of T, it's kind of a piecewise function for T greater than 6, right? Remember, so we're taking gas out up until 6, but then our rate of change has to change. So we got to start at 6, and I know at 6, which is 2 p.m., there's 9,471 gallons in there. So I'm allowed to rewrite a new function for G, starting at the 6th place instead of starting at 0. Okay, and it'll be the same thing, except for, we're going to go to T. My rate of change is now just R of T. It's really 0 minus R of T, because my rate in is now 0, because we're not pumping any more gas in. Okay, so how much gas is there at 4? We need G. And you can do this a couple different ways, but the way I have to find it is we need G of, that would be 8, right? 8 hours after we've opened. So it's 9,471 plus that integral, right? Which I'm not going to write out. I'm just going to do it on my calculator. So it's 9,471 plus math 9. And we're going from 6 to 8. All right, so sometimes kids want to go 0 to 2, but you got to keep track of time the whole way through here. All right, so we're going 6 to 8, and we're integrating just the rate out, which, well, 0 minus the rate out. We'll put that in there. And I put my rate out as Y1. And I hope I didn't confuse those. I normally write those down on my screen somewhere, but that's going to tell us. It should be less than it, right? Yeah. So 9434.333. Gallons. It's an A. Okay. And that is that. That's the fundamental theorem of calculus with accumulation problems.